Scotland Data Science and Technology Meetup Group. Special guest here tonight, Harvinder. Harvinder's going to do his own intro in a couple of minutes. Just a big welcome to everybody, wherever you are in the world. Thanks for joining. Chat box is open, and as is traditional with these things, it would be really good for anybody who is in the chat to let us know whereabouts the world you're from. This virtual event is a version of an event that we normally run from either the offices in Glasgow or from Data Lab in Edinburgh or from further afield, sometimes up in Aberdeen. But this is obviously a virtual event, and it's nice to know where everybody's tuned in from. Tonight we should be hearing from Harvinder for around 35-40 minutes of his presentation, and then obviously a Q&A at the end. If you have any questions for Harvinder, please feel free to populate the Q&A box. If you just stick your question in there, then myself or Harvinder will get to them afterwards. Normally, if we were doing this in the flesh, you would be supplied with drinks and nibbles. I'm hoping everybody's brought their own. Drinks should be in the beer fridge where you left them, and your nibbles should be in the cupboards. That's about it from me. Sorry, I should have done an intro to myself. I'm Rob Huggins, Director of Client Services at MBN Solutions, but you're not here to hear from me. So I'm going to shut up now. I'm going to pass you over to the man Harvinder. Hopefully, we're off and running.
Thanks, Rob. So I'm just sharing my screen now. Hopefully it's coming through.
Brilliant. We can see you. Brilliant.
Yeah, perfect. Right. Okay, so a little quick intro from me. So I'm Harvinder. I head up the data function at Moneysupermarket. So I guess one thing that's slightly different about the way data is organized at Moneysupermarket is I own the entire end-to-end data supply chain, all the way from data capture through to data use. So whether that's product analytics, data science, data analytics, BI, but also data engineering, DBAS, data architects, and so on. So I've actually been working with data and algorithms for a very, very long time, over 25 years. So prior to Moneysupermarket, I had roles at dunnhumby, working on Tesco Club Card, before that, Lloyds Banking Group. But I originally started my career a long time ago in operational research, which I guess was the kind of data science of its day. A little bit about Moneysupermarket, if you're not familiar with it. So we were actually a group of companies. So Moneysupermarket is our main brand. So people come to us when they're looking for a great deal on car insurance, energy, broadband, credit cards, wide range of product. We have Travel Supermarket, which, as the name suggests, is a very similar price comparison website, except it specializes in travel. So holidays, car hire, flights, that sort of thing. Starting to pick up again, obviously quite impacted by COVID. We have Money Saving Expert, which is the UK's biggest consumer affairs website. So I'm sure a lot of you are familiar with Martin Lewis and his newsletter and TV show. And then the newest addition to the group is Decision Tech, which is a B2B business. So they actually work with a lot of sort of fintechs, banks, and actually some of our competitors. So one of the great things about working at Moneysupermarket is that our mission is to help consumers. So last year we helped UK consumers save $2 billion on what they would otherwise would have paid on a range of products. And we actually have a lot of users. So we estimate that over the course of the year, 80% of online adults in the UK will visit one of our websites, which actually makes us bigger in terms of people who will use us over the course of the year than Facebook. So as a course of, our business, we capture a lot of data and we use it in lots of different ways. So it gets used in product creation. So we work very closely with our product teams to design better products and test new features. We use it to improve the customer experience through personalization, and we also use it to improve business efficiency. So particularly things like marketing. And I'm sure everyone on this call has lots of different uses for data. We know that applications just aren't in short supply. You can use data to improve fraud detection, improve marketing, look for anomalies. You can use it in medical diagnosis. There's just endless uses and endless ways that data can make the world better. So actually, we should be living in a world where data is just making a massive difference. But actually, when you look at the data about data, it actually shows something else. It shows something slightly worrying. And it actually says that there's a problem. There's actually a big problem. So here's the results of a survey. So this is from New Vantage Partners. They run a survey of hundreds of companies every single year. So it's really great for looking at trends. And they found in their latest survey that only 7.3% of organizations say the state of their data and analytics is excellent, which is remarkably low. And in case you think that's an isolated survey result, actually it's just one of many that says something very similar. So I think this one was from Ghana. I can't remember exactly which consultancy it was, but they said that only 22% of companies are currently seeing a significant return from data science expenditures. And then if you look bottom up at what data scientists are saying, so Kaggle ran another survey. It's called Kaggle's State of Data and Machine Learning Survey. There are also lots of worrying responses. So, half of data scientists say that, they have to deal with dirty data, that there's a lack of data science talent, the management don't support them. They can't even get hold of the data in many cases. The business don't know what they want from the data, and so on. So you'd think with all these challenges out there that actually people will be trying to do a lot to overcome them. But when you actually go to conferences and meetups, the only thing that people are talking about is technology. So I did this sort of word count of mentions of various topics by speakers at London Strata. And what did the conference talk about? Well, it's one of the biggest data conferences in the world, and they were talking about Spark, Kafka, Hadoop. So, data scientists are saying that they deal with dirty data, lack of talent, lack of support, lack of access to data, and people are saying, well, Spark, Kafka, Hadoop, SQL. So there's a massive disconnect there. People are talking about the technology, but not about the processes and the actual real day-to-day challenges. And the thing is actually that the technology is not as important as people think it is, right? So this is another massive survey by Jess Umberl and Gene Kim, who are kind of founders of the DevOps movement in technology. And they found that there was no significant correlation between system type and delivery performance. And even this surprised them. They were expecting, companies who were working with, brand new technology in the cloud to be outperforming those that weren't. Actually, that wasn't the case. They found no correlation. And again, in case you think I'm cherry picking, back to New Vantage Partners, and one of the questions they ask is, what are the challenges to becoming data driven? And actually, technology is becoming less and less of a challenge with every passing year, because actually it is keeping up. There's a lot of investment, a lot of development, and now it's for a lot of companies, it's just not a blocker at all. There are other challenges as well. So that technology has kept up, but there are other challenges out there. So one is with data science itself, and what data science community talks about. So a lot of junior data scientists, inexperienced data scientists, they think that success is an accuracy score on a model. So there's a lot of focus on things that they control, and one of the things that they can actually control is hyperparameter tuning, the choice of algorithm, and so on. So a lot of effort gets expended in this space. But actually, again, if we look at what's happening, actually there's been remarkably little step change in sort of algorithm performance over the last few years. I mean, there was a massive spurt in innovation in algorithms with deep learning and XGBoost and so on a few years ago, but it seems to be plateauing somewhat. And AutoML is getting better all the time. So historically we used to use Data Robot, but this is something from Google. They're comparing their performance of AutoML tables versus other AutoML vendors versus Kaggle leaderboard. Actually shows pretty impressive performance. Now, obviously, in some cases, having absolute model accuracy is super important. If you're looking at fraud detection, healthcare applications, ad tech, it really is important. But actually, in a lot of business domains, a good enough model and enough good enough models are better than one perfect model. And actually, that that was recognized a long time ago, that actually the algorithms themselves are only a tiny part of what you needed to deliver value from machine learning. So this is from a famous Google paper called The Hidden Technical Debt of Machine Learning. And Google said actually the ML code is a tiny part of what you need. So there's configuration, serving infrastructure, monitoring, and so on. Actually, I think they even Google missed out a whole lot of things. So, you know, that you need good data quality, otherwise it's garbage in, garbage out. You need stakeholder buy-in, version control. You need teams organized around the machine learning process, MLOps, and so on. You need outcome measurement. So actually there's a lot which doesn't actually touch the ML code itself. So no one wants to talk about the lack of value, dirty data, people, process, and culture. All they want to talk about is algorithms and technology. And it's a bit of a challenge because, you know, you need to convince your organization to do things differently. But actually, when you look at it, there's very few people who understand data and how to use it. So maybe there's you, there's your team, hopefully your manager. Obviously, that's not guaranteed. And then there's people who don't understand what you do. And that's basically everyone else. And the problem starts from the very top. So, you know, a lot of organizations, they want to be data driven. They think it's the right thing to do. So, you know, the chief execs, they read up on the latest news, and, you know, they see and hear what other companies are doing. So they start by hoarding data. Then they think they have to hire some really clever people with PhDs called data scientists, give them access to the data, and then some magic shit happens and money flows. But actually, well, in reality, the money does flow, but it actually flows in the opposite direction because technology isn't cheap and data scientists certainly aren't cheap. And then there's a lot of outdated thinking out there as well. So, you know, there's a phrase I would love to ban, which is called actionable insight. So this again comes from the legacy world of, you know, when I started, there was nothing else that you could do, right? So you went into SAS, or you went into a SQL database, you extracted some data, did some analysis, put it into a PowerPoint presentation and said, look, here's a recommendation. And sometimes it was acted on and sometimes it wasn't. It was very much sort of hit and miss who your stakeholder was and so on. But actually the problem with focusing on actionable insight is if it's not going to be action, it's not actually creating value. And this is some stats from Gartner, a forecast really, which says that only 20% of analytical insights will deliver business outcomes. So in terms of steps to overcome all these challenges, number one is really to focus on outcomes and not outputs. So traditionally, people are focused on turning resources into activities into output. So you start with data, you have some data scientists, you get them to do some work, they produce some output. But actually, what we're really interested in is outcomes and impact. And so this is called the program logic model. And what we do is we try and start over on the right-hand side. We say, well, what impact do we want to have? So what we do is we very closely align with the organization. We share objectives with them. We want to make sure that we're both really aligned in what we want to do. And then we flip everything on its head and we say, well, to deliver that impact, what outcomes do we need? What outputs will lead to that outcome? And therefore, what activity and resources do we require? So basically, in order to live that, you need a completely different approach to delivering outcomes from data. So I kind of use this analogy. So this is Thomas Edison's first electricity generator installed in Lower Manhattan in the 1880s. And he installed this, and then absolutely nothing happened for the next 30, 40 years. The world continued to run on steam and gas. So what happened was that in order to use electricity, people had to basically re-engineer and completely re-architect their factories from a single steam engine that ran lots of pulleys to a much more horizontal factory with lots of electric motors instead. And they weren't initially willing to do that. They weren't willing to throw out all the previous investments and move to using electricity. And it took till the sort of 1920s before there was a wholesale change, or when there was a dramatic improvement in productivity. We're kind of very similar journey when it comes to data analytics. There's very historic sort of legacy thinking in this space. So the analogy I use with my sort of exec and board is this, which is, one of the oldest uses of data and computers actually was in telephony, because you needed to send out an accurate bill. You couldn't do it by hand, so computers were ideal. And so computers came along, but computers were really, really expensive. So there's a lot of rigorous systems architecture, development methods, requirement gathering. So a lot of work was done up front before you even got anywhere near a computer. Then someone attached a printer, and MI and BI were born. But really, data was not used beyond the operational use that was required. So once you send your bill out, actually you didn't need that data, you just archived it, stored it somewhere. Very little value, process was done. Then data warehouses came along, but again, they follow the same methodology of big design up front, a lot of requirements gathering, a lot of design work, a lot of development of schemas before actually users were allowed to access the data. And sometimes it could take years, I used to work in organizations where it could take like 2-3 years between putting in a request and being able to access the data in a data warehouse. But we can't apply that steam-age thinking to data anymore. So today, take the same telco is getting data from lots of different sources, from what the customers are viewing, maybe on a set-top box, from their phone calls, from how they're using the internet, and so on. And that data comes in a lot of different formats. So some of it might be nicely structured, but a lot of it will be semi-structured and unstructured data. And it ends up in lots of different silos and marked across the organization. But actually that data needs to be combined and shared across multiple systems, because there are a lot of analytical use cases for it. So, you could use it for fraud detection, cross-selling, A/B testing, marketing effectiveness, financial modeling, you name it. There are lots and lots of use cases where you need to be able to create analytical outputs. And those outputs are actually very critical to decision making. So long after that customer has made the call, long after they visited a website, that data is still being used over and over again to improve the organization's pricing capability, its manpower, its marketing mix, and so on. So now data's gone from being a byproduct to being a competitive requirement. So it needs to become a first-class citizen in the organization. And that means it requires basically a completely different process of its own to be treated as an asset. So basically, that was a long way of saying that data is no longer a byproduct, it is a product in its own right. So number two is that you need to shift from project thinking to product thinking. So DJ Patil, I think you might even have coined the phrase data science. States a product that facilitates an end goal through the use of data as a data product. So if data is a product, then data analytics is complex manufacturing, extremely complex manufacturing. So, you need data storage and databases, you need compute infrastructure, query execution engines, you need all the development tools on top, the software libraries, you need reproducibility, orchestration, monitoring, data management capability, data analytics capability, data creation, data processing, pipelines, ETL tools, and so on, stream processing. And that's just your production system. So to take raw data into a finished data product. But then there's a second process, which is a product development system. So nothing stands still, so you need to keep improving your production system and your outputs. And this is often underestimated by organizations, just the amount of effort required to build this. Now, data isn't unique in having these challenges of complexity. There are other domains where the same things or similar things apply. So the two sort of most common lateral domains are sort of manufacturing and software engineering. And they develop specific methodologies to cope with this complexity and deliver trusted output at speed. So in manufacturing, Toyota came out with just-in-time, now called sort of lean thinking. And in software development, they developed Agile and DevOps. So the intersection of data analytics, lean thinking, Agile, and DevOps is DataOps. So number three, it's important to apply lean thinking to your processes, and that's to eliminate waste and improve quality. So, one of the ironies of data people is that they will use data to tell other people what they do, but not use it themselves. So, one of my offsites, I asked everyone in the room to say, ask them, do you use data to create recommendations or make recommendations for everyone? And everyone, the rest of the organization, everyone's hand went up. And then I said, do you use data to improve your own processes? And not a single hand went up. But actually, being introspective and using data to look at how you deliver work is extremely powerful. So, one of the tools we use is lean process mapping. So you basically map your process against the timeline. And then you look at the amount of time each task takes. So anything that adds value gets plotted above the timeline. Anything that wastes value gets plotted below the line. So things like waiting around or rework are waste. And typically what you find is that in any process, although you think you're busy, actually a lot of your time is spent waiting for things like data to become available, or even finding the data or waiting for resources to be provisioned for you. And then when you look at this process, then you can start to figure out where your bottlenecks are and what you need to do differently to speed things up. And we've used this to quite dramatic effects. So, a few years ago, it used to take us, over 2 years to make a new data attribute or new data item available to end users. And then we've got that down to 3 weeks. We take that down further, but obviously there's still work in terms of, requirements and testing and so on. And then, even when you improve your processes, there's still difficulty. So development and orchestration of production pipelines is very hard in the modern world. So as I said, you've got lots of different sources and data formats. You'll be using lots of potentially different tools as part of your pipelines. And your DAGs, you have lots of data products. So it can become extremely complex. And the reason it's more complex for data is, unlike software engineering, where if you code something up correctly and logic past your unit testing and your acceptance testing, integration testing, and so on. For example, if you code up the logic for a calculator, it will work the same way in 100 years' time as it does today. It will be absolutely correct. As soon as you deploy a data pipeline, you're almost guaranteed that it will break. That's because there's often a lot more complexity in the data than the code itself. And, we have data pipelines that can break for any number of reasons, duplicate data, someone upstream, change a data format for a field and so on. So there's lots and lots of different ways that things can break, and it's really hard to keep on top of it, which means that number 4 is that, you really need to put a lot of monitoring and testing in place to make sure that your data pipelines are trusted and healthy. So, there's a lot of things you can do: file validation, data accuracy checks, data completeness checks, ETL performance, and so on. So then you have to accept that actually there are rules, and especially within the delivery pipeline, that there must be rules and constraints to produce trusted output. And this sometimes comes as a shock to a lot of data scientists and data analysts who just want to do stuff. Because they see rules and constraints as things that get in the way. But actually it's really important that people are able to trust your output and trust you with data. So actually a lot of my time is spent with our sort of risk, legal, compliance, infosec teams, making sure that we are implementing policies around identity and access management, authorization, data classification, and so on. And once you can prove to people that actually, you can be trusted, it actually gives you more freedom because they realize that you are serious individuals. And then you have to figure out how to deliver this all. So all products and projects basically have a life cycle to be managed. So it starts with concept, so ideation, then you have an inception, then you go through a development phase, and then there'll be iterative development. Then your product will go into production, and then eventually you'll go into retirement. So you have to figure out the best way of delivering or managing that life cycle. So what you want with data is really the ability to be adaptable to change. So this is number 6, and obviously Agile is typically one of the ways you can deliver products. Obviously, there's also the waterfall approach, which sometimes can still be appropriate, depending on what you're trying to do. But typically, most people will try to employ some sort of Agile framework. Now, Agile is extremely misunderstood. So a lot of people think Agile is just Scrum, or that if you're having meetings standing up every morning for 15 minutes and working in 2-week sprints, you're Agile, but actually that's not the case. First of all, there are many Agile frameworks out there. So typically we prefer Kanban, or at least Scrumban, which is a combination of Scrum and Kanban. And the reason is that often within the data world, it's really hard to predict or to estimate what you can actually deliver in a 2-week sprint. Often you just don't know until you start looking at data. But whatever you do, the most important thing is that you stay true to the Agile Manifesto values and principles and not implement fake Agile. So make sure that you are valuing people over processes and working prototypes over excess documentation and so on. But Agile will be nothing if you didn't have the ability to make frequent small changes, right? So what would happen would be that you'd be developing very iteratively, making frequent updates, but actually you wouldn't have the ability to deploy them. So what you want is the ability to be able to also deploy work in small batches in order to get feedback. So this is where number 7, DevOps, comes in. So there's a lot that data can learn from DevOps best practice. So DevOps came about because of basically the friction between developers who wanted to make change, an operations team who had to run those products in production, and really didn't want to be woken up at 3 a.m. In the morning because there was an incident or a failure. So they wanted to actually minimize the amount of change. So DevOps came about to kind of bring those two groups of people together to be able to make rapid change and manage it in operations. So one of the first places you can start, if you're not already doing this, is in automated reproducibility. So version control of code. So there's Git, which is obviously the most common way people version code. But obviously there's lots of hubs, if you like, for managing your Git workflows. So we use Bitbucket and so on. So version control of code allows you to not just go back to a known good state of your code, but also allows for things like peer review, branching. So there's a lot of good things that can come out of using version control. But it's not just code that needs to be version controlled. There's also entire environments. So this is where configuration management and configuration orchestration comes in. So historically, people would have made reproducible environments using virtual machines. We kind of tend not to do that so much these days. They're pretty heavyweight. Tend to use containers for that. There's also Conda for sort of package management if you're using Python. And then there's actually the entire sort of infrastructure environment itself. So we typically use Terraform for configuration orchestration, but if you're on AWS, you might be using something like CloudFormation. So what that sort of version control of environments and code allows you to do is to automate the deployment pipeline. So you start with something as simple as continuous integration, which is where when you commit code, you run some unit testing, then you run some integration testing. And then you can go further in the automation. So you can automate things like the acceptance stage as well before deploying to production. And that's known as continuous delivery. So we're not quite there at the final end, but we do a lot in the continuous integration side. And again, just to show you some of the benefits, if you take that approach, you can dramatically make frequent changes much more quickly. So, as an example of machine learning pipeline, you can break it out into various steps and branches, and then you can make changes and test them. So, over time, we've got the time it takes to sort of test changes in a machine learning pipeline down from 11 hours to 5 minutes. So if you're making all that change, there's something else that you need to do. So number 8 is test data management. It's super important. So the reason it's super important is that, as I said, there's a lot of complexity in the data itself. So when you're making changes to your code, you want to know that anything that changes in your output is a result of a change in the code and not a change in the data that you're using. So various different ways to do this. You know, you can have sort of static snapshots of data in the UAT environment, and so on, but it's really important that you do have sort of test data management strategy in place. Number 9 is the people side of things. So it's really important that you look at the way you organize and make sure you organize for success. So you may be familiar with Conway's law, which says that an organization's sort of product or customer experience is a direct result of its internal communication pathways. So here's a famous study from Microsoft. So they looked at why certain code that was produced for Microsoft Vista was more reliable than others. They looked at all the various factors that could have contributed to the reliability of the code, things like code churn, the code complexity, and so on. But what they found was actually the best predictor was actually the organizational structure. So how the teams was organized was the best predictor of the code quality. So historically, teams have been organized in a very functional way by technical expertise. So you'd have a team of data scientists, team of data analysts, team of data engineers, and a team of architects and so on. So the reason teams are organized like this is it's very efficient from a sort of resource utilization cost point of view. I mean, you don't want an architect in every single team. They're expensive. And a lot of time they might just be sitting around waiting for work. When you have functional teams, no one is idle. As soon as someone becomes available, they're assigned a project. However, there's a massive downside to functional teams, which is, while they're optimized resource utilization, they're not optimized for speed. All that happens is that work ends up being queued in other teams' backlogs, and you have this massive coordination problem, which just leads to endless escalation around my project is more important than your project, can you expedite it? So if we again look at the data, we look at the surveys and say, what should we be doing differently? This is again another famous research survey from McKinsey this time. They looked at the difference between companies that were leaders in using analytics versus everyone else. And what they found was that one of the biggest differences was that the leaders employed cross-functional, collaborative, agile teams. So specifically, nearly 6% of what they call the breakaway organizations, so they were the leaders in the space, used cross-functional teams versus less than a third of the remaining respondents. So what you can do is you can look at your sort of personas. So every organization is obviously different. It has different skills and different job titles. But you can look at your sort of core personas and see which of those could fit into a cross-functional team. And not everyone is. So you'll still have some people sitting outside cross-functional teams. So typically we would put like data scientists, data engineers, and data analysts into a cross-functional team. But actually, when we kind of did this, we kind of realized that there's actually still a problem when you do this, which is that you end up moving the silos from teams themselves to within the team. So it's really important that you cross-skill team members. So what you don't want is for people to be working in parallel in the team. So if you've got like one data engineer or one tester who has lots of work queued up, you're actually not solving the bottleneck problem. What you actually want to do is get people to be multi-skilled so that there are no bottlenecks and you can work in parallel. So kind of specifically, it's moving away from the traditional approach where you have specialists. So people who have deep expertise in one thing being led by generalists, so typically managers who know a little bit about a lot of things, to trying to get people to be T-shaped. So in Agile speak, that's generalizing specialists. And they try to go further, so making people multi-skilled, pie-shaped, or even poly-skilled, M-shaped. So you kind of end up with domain-orientated teams. So, we have cross-functional teams which are aligned to domain. So domain for us might be, customer, so marketing, sort of product, app, anything that cuts across verticals. And then we might have a vertical domain team. So we have teams for our brands and our verticals. And so on. And these are long-standing teams. People don't jump from project to project. They stay in those teams. They build up domain expertise, work with the same stakeholders, build up knowledge of the data. And to avoid them becoming isolated and to ensure that there's sort of consistent standards around things like recruitment and ways of working, we bring them together by making sure they're tied up through centers of excellence and analytical specialists. And then we have sort of data management platform teams. So they look after the things that can't be in a cross-functional team and actually can be used across multiple teams. So very simply, their job is to make sure that the other teams and the rest of the organization, in fact, has the data and the platforms in order to be able to do their job. And number 10 is to make sure that you kind of measure and act on feedback. So there's kind of like two dimensions to this. So there's the sort of the viewpoint. So the team will have an internal viewpoint, the customer will have an external viewpoint. And then there's the product versus service concern as well. So a team might be interested in, is its data product healthy? So is it functioning in the way that it should do? Whereas the customer might be interested in, is the outcome of that product meeting their objectives? The team might be interested in its own internal processes, so they might be running retrospectives to understand how well they're performing or doing team health checks. Whereas the customer might be interested in, are the data team working on the right things for the right people? So it's really important that you actually have all these sort of dimensions of feedback covered. And finally, technology. So I've kind of like deliberately left technology till last because you might have gathered right from the very beginning that actually it's not as important as people think it is, and it's not as important as people and process. So just as DevOps is a lot more than the sort of configuration management tools out there, so DataOps is much more than the tools itself. So there's sort of no single DataOps tool that you can buy to do DataOps. Actually, it requires sort of best in breed, combining multiple technologies. Although there are a few vendors out there who make it easier. So, you've got Data Kitchen, Sagi, and so on. But it can be really, really difficult trying to keep on top of all this technology. There is a hell of a lot out there. There's a lot of change, new things being released all the time. So one of the ways we try and manage that complexity is through something called a tech radar. So this is something that ThoughtWorks came up with. So every sort of 6 months, the data architects and the leaders will get together and we'll look at the technology out there and we'll say, what are we using? What could we be using? What are we looked at, but we don't think we need to consider, and so on. So this is one way that we try and manage all that complexity. So I've covered a lot, and there's only so much I can go through in sort of 35, 40 minutes. If you want to find out more, I have written a book. There's not more detail in there, but I'm more than happy to take questions now.
Okay. Absolutely fantastic. Thank you very much, Harvinder. We have some questions. If you want to just divert your attention, I'm hoping you can see it there, the Q&A box, Harvinder. There are a number of questions in there for you. Tim Johnson's asked a couple. An anonymous attendee's asked a couple. If you just want to work your way through, just starting off with Tim's kind of first couple of questions.
Right, so the question is, how do you decide what use cases to prioritize for insight and production? Right, so it starts with making sure that we are very much aligned in the strategy process itself. So we're actually going through this annual cycle internally right now. So we're working through what are the sort of initiatives that we kind of want to land for next year, and we obviously have a big input into that. So we use our sort of data insight, subject matter expertise to feed into the sort of other functional vertical customer plans. So it starts with inputting into the strategy. Then we make sure that we are aligned on objectives, so that we basically have complete alignment in terms of what we deliver is what the rest of the organization wants. And then we break that down further into, so we kind of break things down into sort of epics, stories and tasks. So we go down to the next level of detail around, well, what do we want to deliver based on the value that we think it will create and the effort that will be required to deliver it. So yeah, we tend to start not bottom up with the data, but top down with what's the organization strategy, what are the objectives, what are the things that we can do to support that in terms of developing either insight or data projects that support it.
So I think Tim's got another couple of questions there, Harvinder.
All right, let me. Sorry, I'm not sure I can see them all.
Okay, so I'll just read them out to you.
Yeah,
Tim's
sure.
second question. So would you talk a little bit more about the point you made about money flowing in the opposite direction?
Right, sure.
Organizations, like, do most organizations currently lose money on data science investments? How long might it take to implement your recommendations and reach payback or a positive value gain?
Right, okay. So as kind of mentioned very early on in the surveys, very few organizations are making significant returns on their data science expenditures, especially those that kind of start with investing in sort of big data technology first. In terms of how long would it take to make a payback, so it depends on where you're starting. So if you're relatively greenfield, the way that I would kind of recommend people implement DataOps is to start with a thin slice use case. So look at the entire end-to-end and say, what would be kind of a minimum viable DataOps to introduce? And you can start with, it's gonna have to be a trade-off. So we tend to use sort of prioritization matrix, which takes into account, do you actually have the data of the right quality in the right place? Do you have the technical capability? Is the outcome going to create value? So you can go through that process and you can pick out something that's going to create value, but it's actually feasible, and pick that as your sort of thin slice, minimum viable data ops use case. Deliver that, learn from it, and then expand from there. So it's not necessarily a case of having to wait. So that's the whole point of, Agile and DevOps, it's moving away from the waterfall approach of having to invest a lot of time, money, resource, to deliver something that, 2 years later is not fit for purpose. It is about being very iterative in creating data products, learning from them, and basically improving them, and in some cases abandoning as well. So, people shouldn't be afraid of failure. If something's not working, ditch it and move on.
And another question from Tim. And Tim, thank you very much for your interaction. Are we looking at an 80-20 rule of thumb, where 80% of data science success is organization, and only 20% is what we think of as data science?
Again, it depends on your context, right? So, sorry, can you just repeat that to make sure I'm answering it correctly?
Are we looking at an 80-20 rule of thumb, where 80% of data science success is organization, and only 20% is what we think of as data science?
Right. Yep. I certainly agree with that. Speaking to many of my peers and mentor quite a few sort of people at more junior levels across many organizations, and definitely the feedback I get is it's the organization challenges that are the barriers, rather than the actual data science itself. So the machine learning, the deep learning, whatever you want to call it. Definitely the feedback I get, and I would say, if you can try and overcome some of those organizational process barriers and focus on those, and less necessarily about the purity of data science, That is the thin end of the wedge to actually get success from the more advanced techniques and models that you can implement.
Actually, I'm going to jump in here and be really, really selfish, because I'd scribbled in a few questions myself, and I'm conscious that quite a lot of the folks that would regularly come to our meetups, or that might be viewing this evening, and might be at the beginning of the journey. And my first question for you is specifically, what blockers or challenges could be expected in the move towards creating business value from investment in data? So I'm thinking here, is it, are we going to run into perhaps, a territorial dispute, or is it old-fashioned thinking? Or from your experience specifically, what kinds of blockers and challenges might people expect?
Yeah, I mean, there's going to be multiple. So I'll kind of part the data challenges. So things like data quality and access to data. So one is that people don't understand, so there might be numerate, and there might be data literate to some extent, but they might not understand how best to use data. So this is a common challenge. People will think that you take a bit of data and you can extrapolate some outcome from it. So, give you a ridiculous example. We have a customer's date of birth. We surely should be sending them a birthday card, whereas a data scientist would turn it back on its head and say, well, what do we want the model to predict? And therefore, let's find from the data what helps us predict that. So the thinking is very different between how a data scientist might approach a problem and how someone in the organization thinks data should be used. So that's one barrier. The other is that a lot of people are very experienced in the organization. They're very experienced commercial people, very experienced marketers, and they don't necessarily want to be told by someone that there's a different, better way that they could be doing things. So there is that barrier. The other is that a lot of data scientists, this industry has exploded in the last sort of 5-10 years. So there's a lot of relatively inexperienced people who don't have that domain expertise that the people they're working with have. So it can be very intimidating. You've got to challenge them, and then these people are experts and they're challenging you back. So it takes time, to build up that domain knowledge and know enough to be able to have those sort of robust conversations sometimes. So that's another challenge that people might face. There's also, obviously a lot of businesses, there's just commercial pressure, right? So, a lot of short-termism, we want results today, we don't want to run experiments to test and learn. That might be leaving revenue on the table. So, it's about having that culture of experimentation testing might not exist in a lot of organizations. I've had that challenge in a few organizations, and then my current one and a few others, it's been the complete opposite, where people realize that it's the price of learning is sometimes you fail and sometimes you leave money on the table.
Yep. Great. So back to the Q&A box then. So the next question, and I'll just scroll down slightly here. So firstly, a compliment to you, sir. Great talk, Harvinder. More of a general data science question. For someone trying to break into a data science role, what are the top technical skills that you recommend them focusing on? As someone who's on the lookout for a new job, I do occasionally feel overwhelmed by the amount of knowledge and skills seemingly required for a junior position, sometimes leading to imposter syndrome. And I think, I sympathise with, it's anonymous attendee, they haven't their name, but I think we could all have a degree of sympathy with that standpoint.
Yeah, I know, I sympathise. I mean, a lot of companies are looking for unicorns that don't actually exist. I mean, it's unrealistic to expect someone, who's starting off in their career to have, 10 years experience of, building deep learning models or whatever, or 10 years experience of Python. So I think if you're kind of like starting off in your career, it's best to show that you are generalist to some extent, that you could pick up and learn a sort of variety of skills. So I talk about how we kind of recruit. So yes, we look for a base level of skills, right? So we look for we typically use Python. So, we're looking for competence in using Python. We're looking for, people who, in a previous role, maybe have demonstrated the ability to create value from output. So, if you have done something, whether you worked on a data project or on a data product, try and demonstrate the value that's created. If you haven't, demonstrate how, you have used your technical expertise to, I'm not the world's biggest fan of Kaggle, as you might understand, but if you don't have real life examples, things from deploying your skills elsewhere on something like Kaggle or another competition or some kind of hackathon, just to show that you can practically use your skills is the next best thing. But then, beyond some sort of base foundation for entry-level jobs, what we're looking for more though is sort of the ability to learn. And the ability to be sort of not just commercially focused, but stakeholder focused. So the ability to understand other people's domain and the impact that you might have on it. So we're not looking for people who can, just sit in the corner with their laptop. We do want people who will engage with the rest of the organization. The way we do that, apart from through the questioning, is we get people to do a presentation as well. So, present a piece of work that they're proud of, to see, how they went through the whole problem solving, but also how they would communicate to their stakeholders. So yeah, I wouldn't necessarily get hung up on, having every tick box checked on every possible technical skill. Personally, I try and recruit people who I can see, yes, they've got enough foundation there, enough generalist foundation, but the ability to learn and the ability to be curious, because, we want T-shaped people, we want pie-shaped people, we don't people who are narrow-minded and don't want to learn about data engineering if they're a data scientist, or vice versa.
It's a brilliant point to then the next question. And the next question is from Nicola. And hello, Nicola. Hope you're doing good. Hi, Harvinder. What are your tips to take members of the team on the journey to become T or M shaped?
Yeah. So the cross-functional teams really help. So people will be working with others who have complementary skills. So we find that that's kind of a natural way for people to learn off each other. We do more formal training, so we sponsor people for things like master's courses, certifications, so cloud certifications. Mostly, as I said, we try and recruit for people who are sort of more curious and open to learning, so it's not much of a challenge, but generally I find that data engineers, data analysts are more willing to learn about data science than vice versa. But yeah, I mean, it was difficult in the early days. A lot of people were saying, why do I need these other skills? I just want to be working with the data. I don't want to learn about, the cloud and, DevOps and things like that. But actually, over time, as people are seeing, the way that the cloud has changed, how we kind of deliver data products, how AutoML and things like that have come along, they see that they actually need to widen their skill sets and have deeper knowledge of other domains. Because we work very closely with technology, our IT colleagues, and it's really, really important that we are able to have really sensible conversations with them. Otherwise, they will completely overwhelm you and be a blocker.
Okay, I'm going to be selfish again, because you've naturally taken me to a point where I asked my second question, and I'm just looking back here and I'm thinking from when you first came into the industry, and I'm thinking about my own journey here, and my question is, have the advances in technology hindered the mission of creating business value from investment in data? In other words, are we in danger of chasing new technology for new technology's sake?
I wouldn't say that's a new problem. That challenge has been around more in sort of IT than in data, I'd say. But it's coming across to data. So certainly I kind of see a lot of that kind of like CV driven development, right? Where people want to use some shiny new technology, not because it's the right one. Actually, introducing new technology is often very disruptive for little gain, but purely for their own sort of personal benefit. Sometimes it's okay. I mean, we want people to spike new things and, try new things and want to innovate, but within reason. And it has to be the right tool for the right job. Yeah, I mean, there's lots of things I would love to check out and use new technology, but when you sit down in a cold light of day and do cost benefit analysis, it's like, well, actually, it's not worth it. There's better problems to solve.
Okay, brilliant. So back to the Q&A box, a question here from Ollie. Have you got a preference? So we're going techie a bit for a minute, mate. Going techie. Have you got a preference in terms of machine learning or artificial intelligence software for natural language processing in financial data pools? I work in financial reg tech, and we're just about to start harvesting data from FCA and perhaps purchasing some from EY. It is very difficult to determine which data is good quality and what is landfill. Would you happen to have some pointers?
To be honest, we don't use natural language processing very much, and it's just the nature of our business. And we've done things like topic modeling in the past on NPS responses, so the verbatim, which was useful. We've talked about using it on some of our. So a lot of products we sell have complex documentation. So we've thought about maybe using natural language process to pull out some of the key policy features for our customers, but to be honest, it's not a big part of what we do. So sorry, I'm not an expert in that area.
Thanks very much for the question anyway, Ollie. So we've got a couple of questions here from Pankaj. The first one, how's the journey been from on-demand to DataOps? How long did it take? And what's been the approach to gaining traction? How has the journey been from on-demand to DataOps? How long did that journey take? And what has been the approach to gaining traction?
Yeah. So first thing I want to say is that it's still a journey, right? So this journey will never end because DataOps is about continuous improvement as much as everything else. So we're constantly being introspective and seeing what we can do. But we kind of started a few years ago in a very specific area with personalization. So we needed to make basically we need to demonstrate that data as a function and data science could deliver personalization in a much better way than at the time our marketing organization was proposing, which was very sort of rules-based. Buy a tool, implement some rules, you've got personalization. And we said, well, actually, we've got some really great data and we should be using machine learning to make decisions around what content our customers see and when and so on for personalization. And that started a few years ago. So that was the start of the journey, kind of like prove the value there. And we've been kind of iterating sort of ever since. So it's been an evolutionary journey. And I think it has to be evolutionary. You can't deliver in a big bang. So like I said, best way to start is with a thin slice, something where you can have a lot of influence end to end from the raw data through to the finished output, and also measuring the impact of the output you're having, learning from that, optimizing the process, and then deploying that on other data products in an iterative way. And then at the same time, you're evolving your technology and your platforms as you go along in your architecture.
Okay. And another question for Pankaj. What would you suggest would be a good path to move from batch scoring of machine learning to real-time scoring? What technology would you suggest?
So there's really three ways of deploying machine learning for recommendation. So one is the batch approach, where you score in batch, store the data in a database, and then your serving application will call the database. And we use that. We use that for sort of non-time critical things. So with our CRM email campaigns, it doesn't really matter if they're not refreshed more than once a day. The second approach is you could build the machine learning model, the algorithm into the application itself. Then you're limited to the data that the application has in the online context at the time it needs to make that recommendation. So that would speed up recommendations, but you're obviously limited. So with batch, you can use all the offline data you have to hand to build the models and the predictions. And then the final way is microservice architecture. So you could serve the recommendations using APIs. So you could combine online and offline data. That's my preferred architecture, but there is added complexity there. So, you have to worry about things like latency of API calls and so on. But if that's not an issue for you, that is the route I would recommend, is using microservices so that your serving application doesn't need to know anything about your machine learning model or its architecture. All it needs to know is, what data does it need to pass and what to do with the request, what does it need to pass in the request and what to do with the response. And the two things can be decoupled and developed independently.
Okay, brilliant. Thanks very much for the questions, Pankaj. Now, I need you to put your get your crystal ball out, mate, because the next question is from DV. DV, thanks for your question. Hi, Harvinder. Thanks for the nice insight into the journey to DataOps. Where do you see DataOps in the next 5 years?
Okay.
What do you see the future of DataOps?
Yeah, so I only see this kind of growing as a lot more organizations kind of come around to seeing the challenge. So, we're going through a kind of nice hype cycle at the moment. But at some point, companies will start, questioning, we put all this investment into data science, into, big data platforms and so on. What is the value we're getting out? And then, a lot of organizations are already kind of discovering this. So, I speak to other organizations and, vendors out there. And this is definitely the direction of travel, which is people are saying, well, actually, there's a big overlap between the problems in this space and those within sort of, especially software development.
Yeah.
So we will start having that bleed over into data and DataOps, particularly in larger organizations, I'd say, more than smaller ones. But yeah, I expect DataOps as sort of a collection of methodologies to only be on a sort of upward growth path. I think we're like where DevOps maybe was sort of 10 years ago, or maybe even further back, in that, people are start jumping on it and seeing that actually there are solutions. Vendors are already in the space, which is always a good sign that it's an emerging area if people are making products in the space. So I expect it to be one of the predominant ways that large organizations deliver value from data, through deploying DataOps methodologies to create data products, as opposed to focusing on insight. So essentially data science at scale, where you have a direct connection between the data and the consumer, as opposed to producing decision support recommendations.
Okay, I'm probably going to use this opportunity to be selfish again here. So the last couple of questions, and as you would probably expect, I really kind of want to focus on the people or the talent side of this. And the first question, I'm actually going to roll the two questions into one here, but what do you think the principal people or talent challenge is? If the next 5 years looks the way you think it's going to look, what do you think the people or talent challenges are? And specifically, does data science education at the moment, be it theoretical or commercial, prepare data scientists for what's really needed in this move towards creating business value? I've got my own views on this one, but I'd be interested in, and if we talk about either, the academic institutions that are producing the future data scientists, or the work that they're doing and the on-the-job training that they're getting. If the future looks like this DataOps model, this very product-focused model where we're looking at business value from data, are we training our future data scientists properly?
Short answer is no.
How do we fix that, mate? How do we fix that?
So I think academia has always been different from the world of sort of commerce, or even public sector for that matter. So as you mentioned, it's often very theoretical. When I did my master's in operational research, these challenges existed, right? So we were told that people in the rest of the organization won't understand your algorithm. So we were taught to as much the algorithms, we were taught how to present and do storytelling and so on. So there are some good courses out there that are doing that. I wish there were more. There are conversion courses as well, obviously, that take people with various sort of mostly scientific backgrounds and do conversion courses which do train some of this. But we need to do more of that. But you know, I don't necessarily think that academia would ever change and make that the primary focus above the theory. I think having more sort of data science, maybe like sandwich courses, and placements would be helpful. Yeah, I mean, it's not unique to data science, right? I mean, it's people who do computer science. You know, they're not necessarily taught, you know, DevOps when they're at university. So I think a lot of it is something that you just learn on the job. And to be fair to academia, you know, the processes and ways of working are constantly evolving out there. So it's, you know, it's always a bit of a challenge trying to keep up. So, you know, you have to invest in yourself as an individual to make sure that you are keeping up with the pace and the required skills. And I think individuals themselves have to recognize the technical skills will only get you so far. So it's like that famous book, what got you here won't get you there. So you have to realize your own sort of knowledge gaps, your own skills gaps that you need to fill to get you to the next level.
Okay, and a perfect time to jump back into Q&A, because Cameron's got a question for you here. There are so many options for data courses. What are the best recognised certifications? Yeah, IBM, MIT, edX, we'll throw in the other ones, MOOCs, Coursera's. If we're looking at somebody who's maybe, you know, the CVs come to you and they've got some of their own self-learning on there, what do you recognise as being, you know, the ones for you that really hit the sweet spot?
Okay. So we tend to basically take people who are maybe in their sort of looking for their sort of second or third job. So primarily we're kind of looking for some experience. Like I said, not necessarily of 5-10 years, because very few people have that, but then we're looking for people who kind of demonstrate some kind of passion. So, you know, I'm not necessarily too concerned around what it is, which course or from where. It's just that actually they've got a bit of curiosity and some interest to go over and above their day job, because then that kind of implies that, you know, when if we were to hire them, that actually they would still be hungry to learn, and there is still a lot to learn. So I'm looking for that signal more than anything else. Yeah, I mean, there are some good courses out there. I mean, there's edX, you know, I've done quite a few courses, Coursera, I've done quite a few, but they're more to just, like I said, there's quite a breadth of knowledge that needs to be acquired in this domain. So they're more for me to kind of keep up to date, and I would expect people working for me to also be sort of self-starting, self-learners. So in terms of like academics, you know, if people do have specialized in a sort of data science type masters, and that's a bonus, but not a necessary requirement.
It's yeah, I mean, and we see it an awful lot. It's not necessarily which body the qualification is with. It's the fact that you have gone in your own time for your own, you know, personal satisfaction, that you've undertaken a bit of additional learning in addition to what you're told to do by your job. Yeah, no, absolutely brilliant. Okay, another couple of questions. We've got a couple from Hussein, who starts off by thanking you for the great presentation, sir, and then asking, how would you describe the relationship between AutoML and DataOps?
Right. So yes, so they kind of border each other. So they are different domains. So MLOps is not DataOps. Some people do kind of confuse the two. So MLOps is about the development and operationalization and monitoring and so on of models. DataOps is about the end-to-end creation of that data product. So the kind of, if you like, the data pipeline itself. So the model obviously needs these data to want to train it, but also to do scoring. So AutoML comes in as kind of the very sort of endpoint of that. We have used AutoML ourselves. So We used to use Data Robot before we kind of realized it was just a very expensive way of realizing that XGBoost is the best classification algorithm. And we built our own pipeline. We're looking at Google's AutoML tables as well. So for me, it's part of the entire pipeline, but only the very endpoint. And it's a way of kind of like speeding up the creation of value. Because as I said, in a lot of cases, you don't want to spend time building the perfect model. You want to build the right model that creates value, and build more models that create more value.
A question here from Raul. What industries, and not asking you to big up any competitors here, I'm going to broaden the question out slightly. What industries or organisations do you think have succeeded? So this is coming back to your very original point in those early slides where you mentioned the lack of success in creating of business value, if you like, and the data science investment that had been wasted. But what industries or organisations do you think have succeeded or made more of data science / DataOps practice so far? Is anybody getting it right, other than yourself, obviously?
So I think, I'd say a lot of the sort of digital companies, do data really well. You like see it in your kind of food delivery space, your obvious ones like Deliveroo and Just Eat and so on. I'd say some of the kind of larger legacy organizations don't do it so well. I'd say companies
we were kind of discussing earlier on that the reasons why they don't do it well, there are a variety of factors that kind of conflict with each other.
Yeah, so I mean, I guess it does depend very much on the industry, right? So there's a concept of data offense and data defense in data strategy, right? So on data defense, you're focused on things not going wrong. And in data offense, you're focused on using data to create value. So if you think about certain industries, they're very much focused on data defense, things like financial services, and it would be one area where it's highly regulated. So you're very much thinking about making sure that data is well governed, that you have audit trails, that you have data lineage in place, and so on. You're not thinking about, right, how do we use that data to create data products at rapid pace. And then at the other extreme, you have companies who see data as a kind of strategic asset. And they're very much focused on data offense. So as I said, a lot of sort of digital startups, fintechs might be both camps. Actually, they are regulated, but they want to use data to create new products and new features and services for their customers. So I think, it's definitely down to the industry. Or having said that, pretty much every major bank is moving to cloud. HSBC moves GCP. Can't remember who Barclays is looking at, but so things may change.
Fantastic. This is a very last chance for anybody who's got an additional question for Harvinder. Pop it in at the speed of 1,000 stampeding gazelles. Please pop it into Q&A. If anybody has anything, please stick it in now. Stick your hand in the air. I think that might be us, fella. All right, Harvinder, what can I say, fella? Once again, it's been an absolute pleasure. Every time I hear you speak, mate, I learn something new. Thank you so much for taking the time to talk to the community. I think everybody's learned something from tonight. Thank you to the community. Thanks for everybody that's taken part tonight. Thanks for your questions. Thanks for your enthusiasm. That's it from me. Passing over to Michael for the final word.
No, just thanks again, Harvinder. It's great to see you again. Great presentation and followed up with some great Q&A. We have done a recording as well, so I'll send that over to yourself. But thanks very much, and thanks very much yourself, Rob. That was brilliant.
Okay, brilliant. Take care, everybody. See you next time. All the very best.
Thanks
Cheers.
again.
Thanks, everyone. Take care.